What if I told you that some of the most mysterious phenomena we've observed in space might actually be evidence that extraterrestrial beings have found ways to break the ultimate speed limit of the universe? Today, you're going to explore one of the most mind-bending questions in modern astrophysics, a question that sits at the intersection of cutting-edge science and our deepest hopes about life beyond Earth. You'll discover how recent observations from our most advanced telescopes have revealed cosmic phenomena that seem to defy everything we thought we knew about the laws of physics, and why some scientists are beginning to ask whether the speed of light might not be the absolute barrier we once believed it to be. If you're curious about these mysteries, please consider subscribing to this channel. I am just starting, and your support truly means a lot to me. Now let's begin. For over a century, this speed limit has been one of the most thoroughly tested and confirmed principles in all of physics. Particle accelerators like the Large Hadron Collider routinely accelerate subatomic particles to 99.9999% of light speed, and the behavior of these particles matches Einstein's predictions with extraordinary precision. Recent observations have revealed phenomena in the universe that seem to challenge our understanding of these speed limits. We've detected jets of material streaming from black holes that appear to be moving faster than light. We've observed the expansion of space itself, carrying distant galaxies away from us at speeds that exceed the speed of light. We've even detected quantum entanglement effects that seem to transmit information instantaneously across vast distances. Each of these phenomena has conventional explanations that don't require breaking the speed of light. But as our instruments become more sensitive and our observations more detailed, we're discovering that the universe is far stranger and more complex than we ever imagined. And some of these strange phenomena are making scientists ask uncomfortable questions about whether our understanding of cosmic speed limits is complete. Consider this. We've only been seriously searching for signs of extraterrestrial intelligence for about 60 years. That's less than a human lifetime, and it's an infinitesimally small fraction of the 13.8 billion year history of the universe. If alien civilizations exist and have been developing technology for millions or billions of years longer than we have, what might they have discovered about the nature of space, time, and the fundamental laws of physics? Our own understanding of physics has been revolutionized multiple times just in the past century. We've discovered quantum mechanics, which reveals that reality at the smallest scales operates according to rules that seem to defy common sense. We've learned about dark matter and dark energy, mysterious substances that make up 95% of the universe but remain almost completely unknown to us. We've detected gravitational waves, ripples in the fabric of space-time itself that Einstein predicted but thought would be too weak to ever observe. Each of these discoveries has shown us that the universe is far more complex and mysterious than we previously understood. They've also shown us that our theories, no matter how well tested, are always provisional, always subject to revision when new evidence emerges. This is the context in which we must consider the possibility that extraterrestrial beings might have found ways to circumvent or transcend the speed of light. We're not talking about violating the laws of physics, but rather about discovering deeper laws or more complete theories that reveal new possibilities we haven't yet imagined. Think about it this way: a civilization that's 1,000,000 years more advanced than us would have had 1,000,000 years to study physics, to conduct experiments, to develop technologies, and to explore the universe. What might they have learned in all that time? What discoveries might they have made that we haven't even begun to consider? The search for extraterrestrial intelligence has traditionally focused on looking for radio signals or other electromagnetic communications. But what if advanced civilizations have moved beyond electromagnetic communication entirely? What if they've discovered ways to manipulate space and time directly, to create shortcuts through higher dimensions, or to exploit quantum mechanical effects we don't yet understand. Recent developments in theoretical physics have begun to explore some of these possibilities seriously. Concepts like wormholes, extra dimensions, and quantum teleportation are no longer purely science fiction. They're active areas of research at universities and research institutions around the world. The Alcubierre drive, proposed by physicist Miguel Alcubierre in 1994, describes a theoretical method for faster-than-light travel that doesn't actually require moving faster than light. Instead, it involves contracting space in front of a spacecraft and expanding it behind, creating a warp bubble that carries the ship faster than light without the ship itself ever exceeding the speed of light locally. While the Alcubierre drive requires exotic matter with negative energy density, something we don't know how to create or even if it exists, the mathematics show that such a drive is consistent with general relativity. It doesn't violate Einstein's equations, it exploits them in ways that Einstein probably never considered. But here's what's truly exciting. We're beginning to observe phenomena in the universe that might be evidence of such exotic physics in action. We're seeing things that push the boundaries of our understanding and force us to ask whether the universe might be even stranger and more wonderful than we ever dared to imagine. To understand whether extraterrestrial beings could have broken the speed of light, we need to dive deep into the cutting-edge physics that might make the impossible possible. You see, while Einstein's special relativity seems to prohibit faster-than-light travel, his general relativity, the theory that describes gravity and the structure of space-time itself, is far more flexible and mysterious than most people realize. Let's start with one of the most fascinating predictions of general relativity, wormholes. These theoretical shortcuts through space-time were first discovered in Einstein's equations by Ludwig Flamm in 1916, just months after Einstein published his theory. Later, Einstein himself, working with Nathan Rosen, explored these solutions in detail, which is why they're sometimes called Einstein-Rosen bridges. A wormhole is essentially a tunnel connecting two distant regions of space-time. Imagine space-time as a piece of paper. Normally, to get from one point to another, you'd have to travel across the surface. But if you could fold the paper and punch a hole through it, you could create a shortcut. That's essentially what a wormhole does to the fabric of space-time itself. The mathematics of wormholes is solid. They're legitimate solutions to Einstein's equations. The problem is that naturally occurring wormholes, if they exist at all, would be incredibly unstable. They would collapse faster than light could travel through them. To keep a wormhole open, you'd need something called exotic matter. Matter with negative energy density that creates a repulsive gravitational effect. Here's where things get interesting. While exotic matter sounds like science fiction, we've actually observed negative energy densities in laboratory experiments. The Casimir effect, first measured accurately in 1997, demonstrates that empty space between two conducting plates can have less energy than the surrounding vacuum, effectively creating a region of negative energy density. Dr. Kip Thorne, the Nobel Prize-winning physicist who worked on the science behind the movie Interstellar, has shown that if you could create and manipulate exotic matter, you could not only stabilize wormholes, but potentially create them. A civilization with sufficient technology could, in principle, engineer shortcuts through space-time that would allow effective faster-than-light travel without actually exceeding the speed of light locally. But wormholes aren't the only loophole in Einstein's cosmic speed limit. Let's talk about the Alcubierre drive, one of the most fascinating concepts in theoretical physics. Proposed by Mexican physicist Miguel Alcubierre in 1994, this hypothetical propulsion system doesn't move a spacecraft through space. Instead, it moves space around the spacecraft. The Alcubierre drive works by contracting space in front of a spacecraft and expanding it behind, creating a warp bubble that carries the ship along. Inside the bubble, the spacecraft never exceeds the speed of light relative to its local space, but the bubble itself can move through space at any speed, including faster than light, because it's space itself that's moving, not the ship. What's remarkable about the Alcubierre drive is that it's completely consistent with general relativity. It doesn't violate any known laws of physics, it exploits them. The main obstacle is the enormous amount of energy required. Initial calculations suggested you'd need more energy than exists in the entire observable universe. However, subsequent refinements by physicists like Harold White at NASA's Johnson Space Center have reduced the energy requirements dramatically, though they're still far beyond our current capabilities. In 2012, White's team at NASA began experiments with a device called the White-Jude Warp Field Interferometer, designed to detect microscopic perturbations in space-time that might indicate warp field effects. While they haven't detected anything conclusive yet, the fact that NASA is seriously investigating warp drive physics shows how far these ideas have come from the realm of pure science fiction. But perhaps even more intriguing are recent developments in our understanding of quantum mechanics that might open entirely new possibilities for faster-than-light phenomena. Quantum mechanics, the theory that governs the behavior of matter and energy at the smallest scales, is full of effects that seem to violate our common-sense understanding of reality. Take quantum tunneling, for instance. This is a phenomenon where particles can pass through barriers that classical physics says should be impenetrable. This is happening in your computer right now in every transistor. What's particularly interesting is that recent experiments have suggested that quantum tunneling might be instantaneous. Particles might traverse barriers faster than light. In 2019, a team of physicists at the University of Queensland measured the time it takes for atoms to tunnel through optical barriers. Their results suggested that the tunneling process takes zero time. The atoms appear on the other side of the barrier instantaneously. While this doesn't allow for faster-than-light communication or travel in any obvious way, it shows that nature has ways of circumventing what we think of as fundamental limits. Then there's the phenomenon of quantum entanglement, which we touched on earlier. When particles are entangled, measuring one instantly affects the other, regardless of distance. This correlation appears to be truly instantaneous, not just faster than light, but infinitely fast. While our current understanding says this can't be used for communication, a civilization with a deeper understanding of quantum mechanics might have found ways to exploit entanglement that we haven't imagined. Recent experiments have pushed quantum entanglement to extraordinary scales. In 2017, Chinese scientists demonstrated entanglement between photons on Earth and a satellite orbiting at 500 kilometers altitude. In 2020, researchers achieved entanglement between particles separated by 50 kilometers of optical fiber. Each advance brings us closer to understanding how quantum mechanics might be harnessed for technologies we can barely imagine. But perhaps the most exciting developments come from theories that go beyond both general relativity and quantum mechanics. String theory, loop, quantum gravity, and other approaches to quantum gravity suggest that space-time itself might have a structure far more complex than we currently understand. In string theory, for example, our universe might have extra dimensions beyond the three spatial dimensions and one time dimension we experience. These extra dimensions could provide shortcuts through space-time that would appear as faster-than-light travel from our limited four-dimensional perspective. It's like an ant walking on a garden hose. From the ant's perspective, the hose is essentially one-dimensional, but a flying insect could take shortcuts through the surrounding three-dimensional space. Dr. Lisa Randall at Harvard has proposed models where our visible universe is a four-dimensional brain embedded in a higher dimensional space. Gravity can leak into these extra dimensions, which might explain why gravity is so much weaker than the other fundamental forces. But if gravity can access extra dimensions, perhaps advanced civilizations have learned to do the same. Recent observations from gravitational wave detectors like LIGO and Virgo have given us unprecedented insights into the nature of space-time itself. When black holes collide, they send ripples through space-time that we can now detect with exquisite precision. These observations have confirmed predictions of general relativity with amazing accuracy, but they've also revealed that space-time is far more dynamic and malleable than we might have imagined. Some physicists have proposed that advanced civilizations might be able to create artificial gravitational waves or manipulate existing ones to achieve faster-than-light effects. By creating precisely controlled distortions in space-time, they might be able to surf gravitational waves or create stable warp bubbles that could carry them across cosmic distances. There's also the intriguing possibility of tachyons, hypothetical particles that always travel faster than light. While tachyons have never been observed and would create serious paradoxes if they could carry information, some versions of string theory predict their existence. A civilization that could create or manipulate tachyons might have access to faster-than-light phenomena that we can't yet comprehend. If extraterrestrial civilizations have indeed found ways to break or circumvent the speed of light, we should expect to see evidence of their activities on cosmic scales. This brings us to one of the most fascinating areas of modern astronomy, the search for techno-signatures, observable phenomena that could indicate the presence of advanced alien technology. The concept of techno-signatures has evolved dramatically since the early days of SETI, the search for extraterrestrial intelligence. While traditional SETI focused primarily on radio signals, modern searches encompass everything from optical communications to mega-scale engineering projects that might be visible across interstellar distances. One of the most intriguing possibilities is that faster-than-light travel, if it exists, might leave detectable signatures in space-time itself. Dr. Harold White and his team at NASA have proposed that warp drives would create distinctive patterns of gravitational distortion that could potentially be detected by sufficiently sensitive instruments. These distortions would appear as specific patterns in the cosmic microwave background or as anomalies in the paths of light from distant stars. Think about it this way. When a boat moves through water, it creates a wake that can be seen long after the boat has passed. Similarly, a spacecraft using warp drive or traversing a wormhole might create distortions in space-time that persist and could be detected by advanced gravitational wave detectors. While our current instruments like LIGO aren't sensitive enough to detect such subtle effects, future space-based detectors might be. The European Space Agency's planned Laser Interferometer Space Antenna, or LISA, scheduled for launch in the 2030s, will be sensitive to gravitational waves at much lower frequencies than ground-based detectors. Some physicists have speculated that LISA might be able to detect not just natural sources of gravitational waves, but also artificial ones, including the signatures of exotic propulsion systems. But the evidence for advanced alien technology might be hiding in plain sight in data we've already collected. Dr. James Benford, a physicist and SETI researcher, has proposed that we should re-examine astronomical data for signs of artificial gravitational lensing. Just as massive objects like galaxies can bend light through gravitational lensing, an advanced civilization might use artificial masses or space-time distortions to focus light for communication or energy collection. Recent observations have revealed numerous examples of gravitational lensing that don't quite fit our models. While most of these discrepancies probably have natural explanations, some remain puzzling. The galaxy cluster Abell 3827, for example, shows lensing effects that suggest the presence of dark matter in configurations that are difficult to explain with current theories. Could some of these anomalous lensing effects be evidence of cosmic engineering? It's a long shot, but it illustrates how our improving understanding of gravitational physics opens new avenues for detecting advanced civilizations. Speaking of advanced civilizations, if you're fascinated by ancient mysteries, the Fermi paradox, hidden history, and the search for lost worlds, I explored that in my video called "What If We Are Not the First Civilization on Earth? The Silurian Hypothesis." This video explores the possibility of civilizations before humanity. Check it out after this video. The link is in the description and card above. Now back to our journey. Another fascinating possibility is that faster-than-light travel might be associated with specific types of energy emissions. Theoretical calculations suggest that traversable wormholes would emit characteristic patterns of Hawking radiation, the same type of radiation that causes black holes to slowly evaporate. While this radiation would be extremely faint, it would have a very specific spectrum that would distinguish it from natural sources. Dr. Andrew Friedman at MIT has proposed that we should look for wormhole shadows, distinctive patterns that would appear when a wormhole passes between us and a distant light source. Unlike the shadow of a normal object, a wormhole shadow would show complex distortions and possibly even glimpses of whatever is on the other side of the wormhole. But perhaps the most dramatic techno-signatures would come from civilizations that have learned to manipulate entire stars or even galaxies. The Kardashev scale, proposed by Soviet astronomer Nikolai Kardashev in 1964, classifies civilizations by their energy consumption. A Type II civilization would harness the entire energy output of their star, while a Type III civilization would control the energy of their entire galaxy. If such civilizations exist and have faster-than-light travel, we might expect to see evidence of coordinated activity across multiple star systems. Dr. Jason Wright at Penn State has been leading searches for what he calls galactic scale engineering, evidence of civilizations that have modified entire regions of space. One intriguing observation is the apparent alignment of certain cosmic structures. Some galaxy clusters show alignments and correlations across distances that should be too large for any physical process to create, given the age of the universe and the speed of light. While these alignments are probably coincidental or due to subtle effects we don't yet understand, they raise interesting questions about whether advanced civilizations might be capable of engineering on truly cosmic scales. The Sloan Digital Sky Survey has revealed numerous cosmic voids, vast regions of space that contain far fewer galaxies than expected. The largest of these, the Boötes supervoid, is an almost spherical region about 330 million light-years in diameter that contains only about 60 galaxies, where we'd expect to find thousands. While these voids probably formed naturally through the evolution of cosmic structure, some researchers have speculated about more exotic possibilities. Could an advanced civilization clear out vast regions of space for some unimaginable purpose? Could they be using the matter from these regions for cosmic engineering projects we can't even conceive of? Recent observations of fast radio bursts have added another layer to this mystery. Some FRBs show periodicities and patterns that are difficult to explain through natural processes. FRB 121102, for example, shows a 16-day cycle of activity that has persisted through multiple observations. While this probably has a natural explanation, perhaps a neutron star in a binary orbit, the precision of the timing is remarkable. Dr. Manasvi Lingam and Dr. Avi Loeb have calculated that if FRBs were artificial beacons or propulsion beams, the energy requirements would be consistent with a Type II civilization on the Kardashev scale. They've shown that a civilization harvesting the energy of their entire star could produce FRBs as a byproduct of launching interstellar spacecraft using powerful beamed propulsion. But the search for faster-than-light techno-signatures isn't limited to electromagnetic observations. Advanced civilizations might leave chemical signatures in stellar atmospheres or planetary systems. If they're mining stars for rare elements or disposing of waste products, we might detect unusual abundances of certain isotopes. The star, Przybylski's star, also known as HD 101065, shows extreme chemical peculiarities that have puzzled astronomers for decades. It contains unusually high abundances of rare Earth elements and even appears to contain short-lived radioactive elements that shouldn't exist naturally in a stellar atmosphere. While there are proposed natural explanations, none are entirely satisfactory. Could stars like Przybylski's star be evidence of alien nuclear waste disposal or element synthesis on stellar scales? It's highly speculative, but it shows how our expanding ability to analyze stellar compositions might reveal evidence of artificial modification. Another intriguing possibility is that faster-than-light civilizations might use pulsars as navigational beacons or communication nodes. Pulsars are neutron stars that emit regular pulses of radiation with timing precision that rivals atomic clocks. A civilization with faster-than-light travel would need some way to navigate across the galaxy, and pulsars would provide ideal reference points. Some pulsars show timing anomalies or sudden changes in their pulse patterns that are difficult to explain. The pulsar PSR B1919+21, for example, shows periodic variations in its pulse timing that don't match any known physical process. While these anomalies probably have natural causes, they illustrate the kinds of subtle effects that might indicate artificial manipulation. We're living through what might be the most extraordinary period in the history of the search for extraterrestrial intelligence. For the first time, governments around the world are openly acknowledging that they've observed objects exhibiting capabilities that seem to defy our understanding of physics. These aren't conspiracy theories or grainy photographs. These are official reports from military personnel, backed by multiple sensor systems and analyzed by teams of scientists. On June 2021, the U.S. Office of the Director of National Intelligence released a preliminary assessment on unidentified aerial phenomena, or UAPs, what we used to call UFOs. This report acknowledged 144 encounters by military personnel with objects that displayed extraordinary capabilities. What made this report groundbreaking wasn't just the admission that these objects exist, but the acknowledgement that they demonstrate technologies we don't understand. The objects described in these reports display 5 key characteristics that challenge our understanding of physics: instantaneous acceleration, hypersonic velocities without signatures, low observability, transmedium travel, moving seamlessly between air and water, and the ability to hover without any visible means of propulsion. Some of these objects have been tracked, accelerating from a standstill to hypersonic speeds in less than a second, accelerations that would generate hundreds of G-forces and destroy any conventional aircraft. Commander David Fravor, a Navy pilot with over 20 years of experience, encountered one of these objects off the coast of California in 2004. The object, which came to be known as the Tic Tac due to its shape, demonstrated capabilities that left seasoned military aviators stunned. It could hover perfectly still, accelerate instantaneously, and make right-angle turns at high speed, maneuvers that would be impossible for any known aircraft. What's particularly significant about Fravor's encounter is that it wasn't just a visual sighting. The object was tracked by the advanced radar systems of the USS Princeton, recorded on infrared cameras, and observed by multiple trained observers. The radar operators reported that the object descended from 80,000 feet to sea level in less than a second, a feat that would require speeds approaching 100,000 miles per hour. Dr. Kevin Knuth, a physicist at the University of Albany, has analyzed these observations and concluded that the objects appear to be using some form of field propulsion that negates inertia. This would explain how they can accelerate so rapidly without destroying themselves. Interestingly, this is exactly the kind of effect you'd expect from the theoretical warp drives and space-time manipulation technologies we discussed earlier. The Pentagon has since established the All-Domain Anomaly Resolution Office to investigate these phenomena systematically. They've collected hundreds of additional reports and have begun applying sophisticated analysis techniques to understand what these objects might be. While they haven't concluded that these are extraterrestrial craft, they've explicitly stated that some of the observed behaviors appear to violate the known laws of physics. Dr. Travis Taylor, who served as the chief scientist for the UAP task force, has stated that some of the objects demonstrate capabilities that would require power outputs exceeding the entire nuclear arsenal of the United States. The energy densities involved are so extreme that they suggest either a fundamental misunderstanding of what's being observed or access to physics we haven't discovered yet. But it's not just the US military that's reporting these encounters. In 2020, Japan's Defense Ministry established protocols for reporting UAP encounters after multiple sightings by their pilots. The Chilean government has released video of objects demonstrating similar impossible maneuvers. Even China has acknowledged investigating unusual aerial phenomena that defy conventional explanation. One of the most intriguing aspects of these observations is that many of the objects seem to demonstrate an interest in nuclear facilities. Robert Hastings, who has spent decades documenting UAP encounters at nuclear weapons facilities, has collected testimony from over 160 former US Air Force personnel who have witnessed these objects near nuclear sites. In some cases, these objects have allegedly interfered with nuclear weapons systems. At Malmstrom Air Force Base in Montana, multiple nuclear missiles went offline after security personnel observed a glowing red object hovering over the facility. Similar incidents have been reported at nuclear facilities in Russia, raising the possibility that whatever intelligence is behind these objects has capabilities that extend beyond mere propulsion technology. Dr. Robert McGuire, a former director at the Institute for Defense Analyses, has pointed out that the observed capabilities of these objects align remarkably well with what we'd expect from craft using Alcubierre-type warp drives. The lack of sonic booms despite hypersonic speeds, the ability to make sharp turns without apparent G-forces, and the low observability all match theoretical predictions for vehicles manipulating space-time rather than moving through it conventionally. Recent scientific papers have begun to take these observations seriously as potential evidence of advanced technology. Dr. Matthew Sidagis at the University at Albany has proposed experimental protocols for detecting the signatures of exotic propulsion systems. His team has suggested that UAPs using field propulsion might create detectable perturbations in the Earth's magnetic field or leave traces in the upper atmosphere that could be measured by satellites. The Harvard Galileo project, led by Dr. Avi Loeb, represents perhaps the most ambitious scientific effort to study these phenomena. Using a network of sophisticated telescopes and sensors, the project aims to capture high-resolution images and data of UAPs. Unlike military encounters, which are often classified and limited in scientific value, the Galileo project will make all its data publicly available for analysis by the global scientific community. Dr. Loeb has argued that even if 99% of UAP sightings have conventional explanations, the remaining 1% could represent the most important discovery in human history. He points out that the object's reported behaviors, particularly their apparent ability to accelerate without inertia, suggest they might be using some form of space-time manipulation technology. What's particularly intriguing is that some of the observed behaviors seem to violate not just our engineering capabilities, but our fundamental understanding of physics. Objects have been observed splitting into multiple pieces and then rejoining, appearing and disappearing from radar and demonstrating what appears to be instantaneous communication between separated units. These observations have led some physicists to revisit exotic theories that might explain such capabilities. Dr. Eric Davis, who has worked with the Pentagon on advanced aerospace threats, has suggested that some observations might be consistent with craft exploiting extra dimensions or manipulating the quantum vacuum. While these ideas remain highly speculative, the fact that serious scientists are considering them shows how profoundly these observations challenge our worldview. The implications extend beyond just propulsion technology. If these objects represent extraterrestrial technology, their mere presence in our atmosphere suggests they've solved the problem of interstellar travel. Given the vast distances between stars and the cosmic speed limit imposed by relativity, this would almost certainly require some form of faster-than-light capability. Dr. Hal Puthoff, who has advised various government agencies on advanced aerospace technologies, has proposed that these craft might be using a form of metric engineering, directly manipulating the structure of space-time to achieve their remarkable capabilities. This would align with both the theoretical possibilities we've discussed and the observed characteristics of UAPs. As we delve deeper into the possibility that extraterrestrial beings have broken the speed of light, we must confront one of the most profound mysteries in modern physics: the relationship between quantum mechanics and gravity. You see, at the heart of faster-than-light travel lies a fundamental conflict between our two most successful theories of the universe: quantum mechanics, which governs the very small, and general relativity, which governs the very large. This conflict might actually be the key to understanding how advanced civilizations could transcend the speed of light. Recent experiments have revealed quantum phenomena that seem to dance on the edge of impossibility, hinting at deeper layers of reality that we're only beginning to glimpse. In 2022, the Nobel Prize in Physics was awarded to Alan Aspect, John Clauser, and Anton Zeilinger for their groundbreaking experiments on quantum entanglement. Their work definitively proved that quantum mechanics allows for correlations between particles that Einstein considered impossible, correlations that appear to operate faster than light. Dr. Zeilinger's team in Vienna has pushed these experiments to extraordinary scales. They've demonstrated quantum entanglement between photons separated by hundreds of kilometers, with correlations that appear instantaneous to within the precision of their measurements, less than a billionth of a second. If there's any delay in these quantum correlations, it's far faster than light could travel between the entangled particles. But here's where it gets really interesting. Recent theoretical work by Dr. Leonard Susskind at Stanford and Dr. Juan Maldacena at the Institute for Advanced Study has revealed a profound connection between quantum entanglement and the geometry of space-time. Their ER equals EPR conjecture suggests that entangled particles might be connected by microscopic wormholes, tiny shortcuts through space-time that could explain their mysterious correlations. If this conjecture is correct, it would mean that the universe is far more interconnected than we ever imagined. Every entangled particle pair would be connected by its own tiny wormhole, creating a vast network of quantum connections threading through the fabric of space-time. An advanced civilization that understood how to manipulate these quantum wormholes might be able to scale them up, creating traversable passages through space and time. Dr. Raphael Bousso at UC Berkeley has taken this idea even further, proposing that space-time itself might emerge from quantum entanglement. In this view, what we perceive as the smooth, continuous fabric of space and time is actually a manifestation of countless quantum connections between fundamental particles. If true, this would mean that faster-than-light travel might not require breaking the laws of physics. It might just require understanding them at a deeper level. Recent experiments have provided tantalizing hints that this deeper understanding might be within reach. In 2021, researchers at the University of Waterloo demonstrated that quantum particles can tunnel through barriers instantaneously, not just very quickly, but literally in zero time. This suggests that quantum mechanics allows for processes that transcend our normal understanding of space and time. Even more remarkably, experiments with quantum computers have shown that they can solve certain problems by exploring multiple solution paths simultaneously, as if they're computing in parallel universes. Dr. A. David Deutsch at Oxford, one of the pioneers of quantum computing, has argued that this is evidence for the many worlds interpretation of quantum mechanics, where every quantum event branches into multiple parallel realities. If parallel universes exist, they might provide pathways for faster-than-light travel that don't violate causality in any single universe. An advanced civilization might have learned to navigate between these parallel realities, appearing to travel faster than light from our perspective, while actually taking shortcuts through the quantum multiverse. But the quantum realm holds even stranger possibilities. Recent observations of cosmic rays have revealed particles that seem to violate fundamental symmetries of nature. The ANITA experiment in Antarctica has detected high-energy neutrinos that appear to be traveling backward through the Earth, a phenomenon that should be impossible according to our current understanding of physics. Dr. Neil Turok at the Perimeter Institute has proposed that these anomalous neutrinos might be evidence of CPT symmetry violation, a breakdown of one of the most fundamental principles in physics. If CPT symmetry can be violated, it would open the door to exotic phenomena like particles that travel backward in time or regions of space where the laws of physics operate differently. The Large Hadron Collider has also produced puzzling results that hint at new physics beyond our current theories. Certain particle decays show slight preferences that shouldn't exist according to the standard model of particle physics. While these anomalies are subtle, they might be pointing toward extra dimensions, new forces, or other phenomena that could enable faster-than-light travel. Dr. Nima Arkani Hamed at the Institute for Advanced Study has proposed that our universe might be a three-dimensional surface embedded in a higher dimensional space. In this scenario, what we perceive as the cosmic speed limit might only apply to motion within our three-dimensional brain, while shortcuts through higher dimensions could allow for effective, faster-than-light travel. Recent observations of black hole mergers by LIGO have provided unprecedented insights into the extreme physics of space-time. When black holes collide, they create gravitational waves that ripple through the fabric of space and time. But careful analysis of these signals has revealed subtle features that some physicists interpret as evidence for extra dimensions or modifications to general relativity. Dr. Claudia Durham at Imperial College London has developed theories of massive gravity that modify Einstein's equations in subtle ways. These modifications could allow for phenomena like gravitational shielding or the creation of stable wormholes, exactly the kinds of effects that might enable faster-than-light travel. But perhaps the most intriguing development comes from the study of dark energy, the mysterious force that's causing the universe's expansion to accelerate. Dark energy makes up about 68% of the universe, yet we have almost no understanding of what it is or how it works. Some physicists have proposed that dark energy might be related to the quantum vacuum, the seething sea of virtual particles that fills empty space. If advanced civilizations have learned to manipulate the quantum vacuum, they might be able to harness dark energy for propulsion or even to modify the local properties of space-time. Dr. Harold White's experiments at NASA's Eagle Works laboratory have attempted to measure tiny perturbations in the quantum vacuum that might indicate warp field effects. While the results remain controversial, the fact that NASA is investigating these possibilities shows how seriously the scientific community is beginning to take these ideas. The connection between consciousness and quantum mechanics adds another layer to this mystery. Some interpretations of quantum mechanics suggest that consciousness plays a fundamental role in collapsing quantum possibilities into definite realities. If consciousness is indeed fundamental to the structure of reality, advanced civilizations might have developed technologies that interface directly with the quantum realm through conscious intention. Dr. Stuart Hameroff at the University of Arizona and Sir Roger Penrose at Oxford have proposed that consciousness itself might be a quantum phenomenon occurring in microtubules within brain cells. If consciousness operates at the quantum level, it might have access to non-local effects that transcend the normal limitations of space and time. As we contemplate the possibility that extraterrestrial beings have broken the speed of light, we must confront one of the most haunting questions in all of science. If faster-than-light travel is possible, if the universe is teeming with advanced civilizations zipping between the stars, then where is everybody? This is the heart of what physicist Enrico Fermi famously asked over lunch at Los Alamos in 1950, a question that has become known as the Fermi paradox. The paradox becomes even more acute when we consider faster-than-light travel. If civilizations can transcend the cosmic speed limit, then the entire galaxy becomes accessible within reasonable timescales. A civilization with faster-than-light technology could colonize the entire Milky Way in just a few million years, a cosmic eye blink compared to the billions of years that life has existed on Earth. Yet we see no evidence of such galaxy-spanning civilizations. The universe appears silent and empty despite all the reasons it should be bustling with activity. This silence has led scientists to propose the concept of the Great Filter, some extremely difficult or improbable step in the evolution of life and intelligence that prevents most planets from developing spacefaring civilizations. The disturbing question is, does the Great Filter lie in our past, meaning we're one of the lucky few to have made it this far? Or does it lie in our future, meaning that something prevents civilizations from spreading across the galaxy even after developing advanced technology? Dr. Robin Hanson, who originally proposed the Great Filter concept, has suggested several possible candidates. Perhaps the emergence of life itself is extraordinarily rare. Perhaps the jump from simple to complex cells is the bottleneck. Perhaps intelligence rarely evolves, or technological civilizations almost always destroy themselves before achieving interstellar travel. Each possibility has profound implications for our own future and for what we might expect to find as we search the cosmos. But recent observations have added new dimensions to this puzzle. The Kepler Space Telescope and its successor, TESS, Transiting Exoplanet Survey Satellite, have revealed that planets are incredibly common. Nearly every star appears to have planets, and many of these worlds orbit in the habitable zone where liquid water could exist. The raw materials for life seem to be everywhere. Dr. Sara Seager at MIT has calculated that our galaxy alone contains at least 40 billion potentially habitable planets. If even a tiny fraction of these worlds developed life, and a tiny fraction of those developed intelligence, there should still be millions of technological civilizations in our galaxy. The fact that we haven't detected any of them becomes increasingly puzzling with each new exoplanet discovery. This has led some scientists to propose more exotic solutions to the Fermi paradox. Dr. Milan Cirkovic at the Astronomical Observatory of Belgrade has suggested that advanced civilizations might deliberately hide from younger species like us. This zoo hypothesis proposes that Earth is essentially a nature preserve, with advanced civilizations observing us but choosing not to interfere with our development. If these civilizations have faster-than-light travel, enforcing such a policy becomes much more feasible. They could monitor vast regions of space and ensure that no civilization makes contact before reaching a certain level of development. From our perspective, the universe would appear empty even though it's actually full of watchful eyes. Another possibility, proposed by Dr. John Smart, is the Transcension hypothesis, the idea that advanced civilizations don't expand outward into space, but inward into ever smaller scales. As civilizations advance, they might discover that the most efficient way to compute, communicate, and experience reality is at microscopic scales. They might upload their consciousness into quantum computers or even encode themselves in the fabric of space-time itself. This would explain why we don't see evidence of galaxy-spanning civilizations. They're not interested in conquering space because they've found something better. They might exist all around us, operating at scales we can't perceive, occasionally manifesting as the anomalous phenomena we've been discussing. Recent developments in astrobiology have revealed just how resilient life can be, making the absence of detectable civilizations even more puzzling. We've found organisms thriving in conditions that would have been considered impossible just decades ago, in boiling acid pools in rocks miles underground, even in the radioactive cooling pools of nuclear reactors. Dr. Christopher McKay at NASA's Ames Research Center has shown that life could potentially survive on worlds we never considered habitable. Jupiter's moon Europa, Saturn's moon Enceladus, and even the methane lakes of Titan could all potentially harbor life. If life is this adaptable, why don't we see evidence of it everywhere? The discovery of Oumuamua in 2017 added another piece to this puzzle. This interstellar object, the first confirmed visitor from another star system, exhibited properties that puzzled astronomers. Its unusual shape, its lack of a cometary tail, despite passing close to the Sun, and its slight acceleration as it left our solar system, led some scientists, including Dr. Avi Loeb, to suggest it might be artificial. While most astronomers believe Oumuamua was a natural object, perhaps a fragment of a destroyed planet, or a cosmic dust bunny of ultralight material, its detection proves that objects do travel between star systems. If natural objects can make the journey, surely artificial ones could too. The fact that we detected an interstellar visitor so soon after developing the capability to spot them suggests such objects might be relatively common. This brings us to a disturbing possibility. What if faster-than-light travel is possible, but civilizations that develop it don't last long? The same physics that enables faster-than-light travel might also enable weapons of unimaginable destructiveness. A civilization that can manipulate space-time might also be able to create artificial black holes, trigger vacuum decay, or unleash other existential threats. Dr. Max Tegmark at MIT has calculated that the vulnerable world hypothesis becomes more severe as technology advances. There might be technologies that are so dangerous that their discovery almost inevitably leads to extinction. Faster-than-light travel, with its implied mastery over space-time and energy, might be coupled with such dangerous capabilities. But there's another more optimistic possibility that recent observations support. What if advanced civilizations are out there, using faster-than-light technology, but in ways that are inherently difficult for us to detect? The UAP phenomena we discussed earlier might be evidence of exactly this. Advanced technology operating in our atmosphere but remaining just beyond our ability to definitively identify or understand. Dr. Jacques Vallée, one of the most respected researchers in this field, has proposed that the phenomenon might be even stranger than extraterrestrial visitors. He suggests that what we're observing might be interdimensional rather than interstellar, manifestations of intelligence from parallel realities or higher dimensions rather than distant stars. This would align with both the reported capabilities of UAPs and our theoretical understanding of how faster-than-light travel might work. If these objects are using higher dimensional physics or quantum effects to achieve their remarkable capabilities, they might naturally be difficult to observe or understand with our current technology. The search for extraterrestrial intelligence has recently expanded to include new types of observations that might detect faster-than-light phenomena. The Breakthrough Listen project, funded by Yuri Milner, is using some of the world's most powerful telescopes to search for signs of advanced technology across millions of stars. Dr. Andrew Semyon, who leads the Breakthrough Listen science team, has pointed out that we've only searched a tiny fraction of the possible parameter space. It's like looking for fish in the ocean by examining a single glass of water. As our search capabilities expand, we might discover that the universe is full of signals we simply weren't equipped to detect before. Recent observations of mysterious radio signals from the direction of Proxima Centauri, our nearest stellar neighbor, illustrate both the promise and challenges of this search. The signals, detected by the Parkes Radio Telescope in Australia, showed characteristics that initially seemed artificial: narrow bandwidth, frequency drift, consistent with a transmitter on a rotating planet, and no obvious natural explanation. While further analysis suggested these signals were likely human-made interference, the episode demonstrated our improving ability to detect and analyze potential techno-signatures. It also showed how challenging it is to distinguish between artificial signals from advanced civilizations and the countless sources of interference in our increasingly radio-noisy world. What if the key to understanding faster-than-light travel lies not in exotic physics or advanced engineering, but in the nature of consciousness itself? As we push deeper into the mysteries of the universe, we're discovering that the boundary between mind and matter, between observer and observed, might be far more fluid than we ever imagined. This isn't mysticism, it's cutting-edge science that's revealing profound connections between consciousness, quantum mechanics, and the structure of reality. Recent experiments at the Institute of Noetic Sciences, led by Dr. Dean Radin, have demonstrated that human consciousness can influence quantum random number generators at statistically significant levels. While the effects are subtle, they're consistent and reproducible across thousands of trials. Even more intriguingly, these effects seem to transcend spatial separation. Participants have influenced quantum systems from thousands of miles away. This research builds on decades of quantum physics experiments showing that the act of observation fundamentally changes quantum systems. The famous double-slit experiment demonstrates that particles behave differently when they're being observed versus when they're not. But recent variations of this experiment have revealed even stranger phenomena that challenge our understanding of space, time, and causality. Dr. John Wheeler, the physicist who coined the term black hole, proposed a thought experiment called the delayed choice quantum eraser. This experiment, now successfully performed in laboratories around the world, shows that observations made in the present can apparently influence events in the past. Particles seem to know whether they'll be observed before the observation actually happens, suggesting that information can flow backward through time at the quantum level. If consciousness can influence quantum systems, and if quantum effects can transcend normal space-time limitations, then advanced civilizations might have developed technologies that harness consciousness directly. Instead of building mechanical spacecraft that push against the cosmic speed limit, they might have learned to project consciousness across cosmic distances instantaneously. Dr. Stuart Kaufman, a theoretical biologist and complex systems researcher, has proposed that consciousness might be a fundamental feature of the universe, like mass or charge. In this view, what we call faster-than-light travel might actually be the movement of conscious information through quantum fields that permeate all of space. This idea gained support from recent discoveries in neuroscience. Dr. Christoph Koch at the Allen Institute for Brain Science has shown that consciousness appears to be associated with integrated information, complex patterns of connection and communication between different parts of a system. But here's the fascinating part. These patterns of integrated information might not be limited to biological brains. The integrated information theory developed by Dr. Giulio Tononi suggests that any system with sufficient integrated information could be conscious, including, potentially, quantum fields, planetary atmospheres, or even the universe as a whole. If consciousness is indeed a fundamental feature of reality, then the universe might be far more alive and aware than we ever imagined. Recent observations from the James Webb Space Telescope have revealed galaxies that seem too mature for their age, forcing us to reconsider our models of cosmic evolution. Some of these galaxies, existing just a few 100 million years after the Big Bang, show levels of organization and complexity that should have taken billions of years to develop. While astronomers are working on natural explanations, these observations remind us how much we still don't understand about the universe's development. Could some of these anomalously mature galaxies be evidence of conscious intervention in cosmic evolution? If advanced civilizations can manipulate space-time and travel faster than light, they might also be able to accelerate the development of entire galaxies, seeding them with the conditions necessary for life and intelligence to flourish. The Pentagon's recent acknowledgement of UAP encounters has included reports of objects that seem to respond to the thoughts or intentions of observers. Military pilots have reported that these objects appear to anticipate their maneuvers, staying just out of reach or positioning themselves in ways that suggest awareness of the pilot's intentions. While this could be explained by advanced sensors and predictive algorithms, some researchers wonder if it indicates a more direct consciousness-to-consciousness interaction. Dr. Gary Nolan at Stanford University, who has been analyzing materials allegedly recovered from UAP encounters, has found isotopic ratios that don't match any known terrestrial or meteoritic sources. But even more intriguingly, he's discovered that many of the military personnel who have had close encounters with UAPs show unusual patterns of brain connectivity, particularly in areas associated with intuition and pattern recognition. This has led to speculation that faster-than-light phenomena might require not just advanced technology, but also enhanced consciousness or perception. Perhaps the ability to transcend space-time limitations requires a fundamental shift in how consciousness interfaces with reality, a shift that advanced civilizations have mastered but that we're only beginning to glimpse. The Global Consciousness Project, running continuously since 1998, has collected data suggesting that human consciousness becomes more coherent during events of global significance. Random number generators around the world show subtle but statistically significant deviations from randomness during events like natural disasters, terrorist attacks, or moments of global celebration. While the interpretation of these results remains controversial, they hint at a level of consciousness connectivity that transcends physical separation. Dr. Roger Penrose, the Nobel Prize-winning physicist, has proposed that consciousness might involve quantum processes in brain microtubules that connect to the fundamental structure of space-time itself. His orchestrated objective reduction theory, developed with Dr. Stuart Hameroff, suggests that consciousness might literally be a window into the quantum geometry of the universe. If Penrose and Hameroff are correct, then consciousness isn't produced by the brain. It's accessed by the brain. The brain might be more like a receiver tuning into cosmic consciousness fields than a generator creating consciousness from scratch. Advanced civilizations might have learned to enhance this reception, accessing levels of cosmic consciousness that grant them abilities we would consider miraculous. Recent experiments with psychedelic compounds have provided unexpected insights into these possibilities. Studies at Johns Hopkins and Imperial College London have shown that substances like psilocybin and DMT create states of consciousness where subjects report experiencing timelessness, unity with the cosmos, and encounters with seemingly autonomous entities. Dr. Robin Carhart Harris at Imperial College has shown that psychedelics reduce activity in the brain's default mode network while increasing connectivity between normally separate brain regions. This creates states of consciousness that might be closer to the fundamental quantum nature of reality, states where the normal limitations of space and time seem to dissolve. While we must be careful not to conflate subjective experiences with objective reality, the consistency of these reports across cultures and individuals suggests they might be accessing real aspects of consciousness that are normally filtered out by our everyday awareness. If consciousness is indeed fundamental to the universe, then altered states might provide glimpses of the deeper reality that advanced civilizations have learned to navigate. The search for extraterrestrial intelligence has recently expanded to include searches for consciousness-based communications. Dr. Stephen Greer's CE5 protocols claim to facilitate contact with extraterrestrial intelligence through meditation and conscious intention. While mainstream science remains skeptical, the number of reported anomalous experiences following these protocols has prompted some researchers to take a closer look. The intersection of consciousness research and the search for faster-than-light phenomena opens up possibilities that challenge our most basic assumptions about reality. If consciousness can transcend space-time limitations, if information can flow backward through time, if the universe itself is conscious, then faster-than-light travel might not require breaking the laws of physics. It might just require expanding our understanding of what those laws really mean. As we stand on the brink of potentially transformative discoveries, we must remain both open-minded and rigorously scientific. The universe has surprised us before with phenomena that seemed impossible until we understood them better. Radio waves, nuclear energy, and quantum entanglement all seemed like magic until science revealed the deeper principles behind them. As we approach the culmination of our journey through the possibilities of faster-than-light travel by extraterrestrial beings, something remarkable is happening. Multiple lines of evidence, from theoretical physics to astronomical observations, from military encounters to consciousness research, are beginning to converge on a stunning possibility. We may be on the verge of the greatest paradigm shift in human history. Consider what we've discovered just in the past few years. The detection of gravitational waves has proven that space-time itself can ripple and flex. Quantum experiments have shown that entanglement operates beyond the constraints of distance and possibly even time. Military sensors have tracked objects performing maneuvers that should be impossible according to our current physics. Astronomers have found cosmic structures and phenomena that challenge our understanding of how the universe evolves. Each of these discoveries alone might be dismissed as an anomaly or explained away with conventional physics. But taken together, they paint a picture of a universe far stranger and more flexible than we ever imagined. A universe where the cosmic speed limit might be more like a cosmic speed suggestion for those who know the right shortcuts. Dr. Eric Weinstein, a mathematician and physicist who has worked on theories of everything, has pointed out that we might be in a crisis of foundations similar to the one physics experienced at the turn of the 20th century. Just as the discovery of radioactivity and the photoelectric effect led to quantum mechanics and relativity, our current anomalous observations might be pointing toward a new, deeper understanding of reality. The Breakthrough Physics Propulsion Project, though officially discontinued by NASA, laid important groundwork for understanding how faster-than-light travel might be achieved. Dr. Mark Millis, who led the project, identified several promising avenues: manipulating inertia, creating space-time distortions, exploiting quantum vacuum effects, and harnessing higher dimensional physics. What's remarkable is that recent observations of UAPs seem to demonstrate exactly these kinds of effects. Recent papers published in peer-reviewed journals have begun to take these possibilities seriously. Dr. Kevin Knuth's analysis of UAP accelerations published in the journal Entropy demonstrates that the observed movements would require power outputs exceeding our entire global energy production. Yet the objects show no evidence of conventional propulsion, no exhaust, no sonic booms, no heat signatures consistent with such enormous energy expenditures. This has led physicists to reconsider exotic propulsion mechanisms that were once relegated to science fiction. Dr. Jack Sarfati has proposed that UAPs might use a form of metric engineering, directly manipulating the quantum vacuum to create regions of reduced inertia. In these regions, objects could accelerate to enormous speeds with minimal energy input, effectively sliding through space-time rather than pushing against it. The implications of these technologies, if they exist, extend far beyond just transportation. A civilization that could manipulate space-time at will would have access to almost unlimited energy. They could slow down or speed up time in localized regions. They could create cloaking effects by bending light around objects. They could potentially even create stable wormholes for instantaneous communication or travel across cosmic distances. But here's what's truly profound. If such civilizations exist and are visiting Earth, it suggests that faster-than-light travel is not just possible, but perhaps even common among advanced species. This would mean that the universe is fundamentally more connected and accessible than we ever dared to hope. The cosmic loneliness that has haunted humanity since we first understood the vast distances between stars might be an illusion created by our limited technology. Dr. Beatriz Gato Rivera at the Spanish National Research Council has calculated that if faster-than-light travel is possible, then our galaxy could contain millions of advanced civilizations, with Earth being visited regularly by automated probes or crewed vessels. The fact that we don't see obvious evidence of this might not mean they're not here. It might mean they're operating under protocols or physics that make them naturally difficult to detect. Recent developments in metamaterials science have shown how objects could be made nearly invisible to electromagnetic radiation. Researchers at Duke University and other institutions have created cloaking devices that work for specific wavelengths of light. An advanced civilization might have perfected such technologies, making their spacecraft invisible across the entire electromagnetic spectrum. The To the Stars Academy, founded by former Blink-182 musician Tom DeLonge, but staffed by serious scientists and former intelligence officials, has claimed to possess materials from crashed UAPs that show extraordinary properties. While these claims remain controversial, the involvement of credible scientists like Dr. Hal Puthoff suggests that at least some researchers believe physical evidence of advanced technology exists. Dr. Diana Pasulka at the University of North Carolina, who has studied the cultural impact of UFO beliefs, has documented how the phenomenon seems to be entering a new phase of mainstream acceptance. Scientists who would have risked their careers by expressing interest in UAPs just a few years ago are now openly calling for rigorous study of the phenomenon. This shift in scientific attitudes coincides with rapid advances in our own technology. We're developing quantum computers that can perform calculations impossible for classical computers. We're detecting gravitational waves and using them to observe cosmic events. We're creating artificial intelligence systems that can recognize patterns beyond human capability. Each advance brings us closer to understanding how truly advanced civilizations might operate. The European Space Agency's LISA mission, scheduled for the 2030s, will be able to detect gravitational waves at frequencies impossible to observe from Earth. Some physicists have speculated that LISA might detect not just natural sources like merging black holes, but also artificial gravitational wave signals, perhaps even the signatures of faster-than-light propulsion systems. Dr. Paul Davies at Arizona State University has proposed that we should look for techno-signatures, not just in electromagnetic signals, but in the fundamental structure of matter itself. An advanced civilization might leave messages encoded in the atomic structure of elements, in the genetic code of life, or even in the laws of physics themselves. The fact that our universe seems remarkably fine-tuned for the existence of life and intelligence might not be a coincidence. It might be evidence of cosmic engineering on scales we can barely imagine. Recent observations of dark matter and dark energy have revealed that 95% of the universe consists of substances we don't understand. What if some of what we call dark matter is actually the infrastructure of advanced civilizations? Dr. Caleb Scharf at Columbia University has proposed that alien civilizations might upload themselves into dark matter computers, living in a realm that barely interacts with normal matter but permeates the entire universe. The convergence of evidence from multiple fields creates what systems theorists call an emergent pattern, a larger truth that becomes visible only when you step back and look at all the pieces together. Each UAP sighting, each quantum experiment, each astronomical anomaly, each theoretical breakthrough adds another piece to a puzzle that's revealing a universe far more alive and interconnected than we ever imagined. But this convergence also places humanity at a crucial crossroads. If we're on the verge of discovering that faster-than-light travel is possible, that we're not alone, that the universe is full of advanced civilizations, how do we prepare for such a revelation? How do we ensure that this knowledge benefits all of humanity rather than leading to conflict or exploitation? Dr. Stephen Dick, former NASA chief historian, has written extensively about the impact that discovering extraterrestrial intelligence would have on human civilization. He argues that it would be comparable to the Copernican revolution, fundamentally changing our understanding of our place in the universe. But unlike the Copernican revolution, which unfolded over centuries, this shift might happen in years or even months. The psychological impact alone would be profound. Every religion would need to grapple with the existence of non-human intelligence. Every philosophy would need to expand to encompass a universe full of other minds. Every human institution, from governments to educational systems, would need to adapt to a fundamentally new reality. But there's also enormous potential for positive transformation. Access to faster-than-light technology would open up the entire universe for human exploration and settlement. Contact with advanced civilizations could provide solutions to our most pressing problems, from climate change to disease to the threat of nuclear war. We might learn that the challenges we face are common to developing civilizations and that there are proven paths forward. Here we are at the threshold of what might be the most profound moment in human history. As you've journeyed through the evidence, the theories, and the implications of faster-than-light travel by extraterrestrial beings, you've seen how the impossible is becoming possible, how the unthinkable is becoming inevitable. The question is no longer whether we're alone in the universe, but rather, are we ready to join a cosmic community that has already transcended the limitations we thought were absolute? The year 2024 marks a turning point in this cosmic awakening. For the first time, mainstream science, government institutions, and public consciousness are aligning around the possibility that we're being visited by intelligences that have mastered physics we're only beginning to understand. The US Congress has held public hearings on UAPs. NASA has appointed a director of UAP research. Scientific journals are publishing papers on exotic propulsion. The tide has turned, and there's no going back. Dr. Gary Nolan's recent statement that he believes with 100% certainty that extraterrestrials have visited Earth represents a watershed moment. Here's a respected Stanford professor, someone with nothing to gain and much to lose, stating unequivocally that the evidence has convinced him he's not alone. A survey of scientists conducted in 2023 found that over 40% now believe it's likely that intelligent extraterrestrial life has visited or is visiting Earth. But what does this mean for you, watching this right now? A conscious being made of stardust, sitting on a pale blue dot in the vast cosmic dark? It means that you're living through possibly the most important transition in the history of life on Earth. You're witnessing humanity's graduation from a single planet species to a potentially interstellar civilization. You're part of the generation that might finally answer the ancient question, are we alone? The evidence we've explored paints a picture of a universe where faster-than-light travel isn't just possible, it might be commonplace among advanced civilizations. The physics that seemed to prohibit it, Einstein's relativity, actually contains within it the seeds of transcendence. Wormholes, warp drives, quantum entanglement, higher dimensions. These aren't just mathematical curiosities. They're doorways to a larger reality that we're just beginning to perceive. Consider what we now know with reasonable certainty. Objects are operating in Earth's atmosphere that demonstrate capabilities beyond our current technology. These objects accelerate without inertia, move between air and water without impedance, and seem to manipulate space-time itself. Multiple sensors, trained observers, and sophisticated analysis all confirm that something extraordinary is happening. The James Webb Space Telescope continues to revolutionize our understanding of the cosmos. It's shown us that galaxies formed earlier and faster than we thought possible. It's detected molecules in exoplanet atmospheres that could indicate life. It's revealed structures and phenomena that challenge our models of cosmic evolution. Each observation brings new questions, new mysteries, and new possibilities. Dr. Avi Loeb's Galileo project has deployed arrays of instruments designed specifically to detect and analyze UAPs. Using machine learning algorithms and multispectrum sensors, the project aims to capture scientific quality data that could definitively prove the existence of non-human technology. The first results are expected soon, and they could change everything. Meanwhile, private companies like SpaceX and Blue Origin are rapidly advancing our own spaceflight capabilities. We're on the verge of becoming a multi-planetary species ourselves. Mars colonies are no longer science fiction, but engineering challenges. The Moon is becoming a stepping stone to the outer solar system. We're taking our first baby steps toward the stars. But here's the profound realization. If other civilizations have achieved faster-than-light travel, our current efforts might be like building better canoes, while others have already invented airplanes. This isn't discouraging, it's exhilarating. It means the limitations we're struggling against have already been overcome. The solutions exist. We just need to discover them, or perhaps be taught them. The implications for human consciousness and spirituality are equally profound. If consciousness is fundamental to the universe, if it's connected to quantum mechanics and the structure of space-time, then we're not just material beings in a material universe. We're conscious nodes in a cosmic network of awareness that spans the stars. Every meditation, every moment of wonder, every act of creativity connects us to this larger consciousness. Dr. Jacques Vallée has suggested that the UFO phenomenon might be a kind of control system, gradually adjusting human consciousness to accept a larger reality. Each sighting, each encounter, each piece of evidence that enters public awareness shifts our collective worldview slightly, preparing us for a revelation that would have been too shocking to accept all at once. This process of disclosure might not be something imposed on us from outside, but rather an emergent property of our own evolution. As we develop better senses, as we ask better questions, As we become more connected globally through the internet and social media, the truth becomes harder to hide. The universe might be revealing itself to us at exactly the pace we can handle. The search for extraterrestrial intelligence has evolved from listening for radio signals to looking for megastructures, from analyzing exoplanet atmospheres to studying consciousness itself. We're casting a wider net with finer mesh, and we're catching things we never expected. Each discovery reinforces the same message: the universe is alive, aware, and waiting for us to wake up. But awakening comes with responsibility. If we're about to join a galactic community, we need to get our house in order. The same technologies that could give us the stars could also destroy us. The same consciousness that could connect us to cosmic intelligence could also be used for manipulation and control. We stand at a crossroads between transcendence and catastrophe. This is why the question of extraterrestrial faster-than-light travel matters so much. It's not just about technology or science, it's about hope. If others have succeeded where we're struggling, if they've survived the challenges we're facing, then we can too. Their existence would be proof that intelligence can overcome its own destructive tendencies and flourish on cosmic scales. The universe has spent 13.8 billion years evolving from a hot, dense state to the magnificent complexity we see today. Stars have formed and died, creating the elements necessary for life. Planets have coalesced from cosmic dust, providing homes for evolution to work its magic. And now, in at least one world, matter has organized itself into forms capable of contemplating their own existence and reaching for the stars. You are part of this cosmic evolution. The atoms in your body were forged in the hearts of dying stars. The information patterns that constitute your consciousness are the universe's way of understanding itself. Your questions, your wonder, your desire to explore and understand, these aren't separate from the cosmic story. They are the cosmic story playing out through you. As we stand on the brink of potentially confirming that faster-than-light travel is possible, that we're not alone, that the universe is full of intelligence and possibility, remember that this isn't the end of our journey. It's the beginning. Everything we've built, everything we've learned, everything we've dreamed has been preparation for this moment when humanity takes its place in the cosmic community. The evidence suggests that extraterrestrial beings have indeed broken the speed of light, or at least found ways around it. They're here, they're watching, and perhaps they're waiting for us to reach a level of scientific and spiritual maturity where contact becomes possible. That moment might be closer than we think. So look up at the stars tonight with new eyes. Those points of light aren't just distant suns. They might be home to civilizations that have mastered the secrets of the universe. The space between them isn't an empty void. It might be crisscrossed with highways of bent space-time, quantum tunnels, and consciousness itself. And you, a collection of atoms contemplating the cosmos, are part of a species that might be on the verge of joining this galactic adventure. The universe is calling us to greatness. It's showing us that the limitations we thought were absolute are actually invitations to transcendence. It's revealing that we're part of something magnificent, mysterious, and meaningful. The question isn't whether extraterrestrial beings have broken the speed of light. The question is, are we ready to follow them to the stars? If you made it this far, please consider subscribing and giving a thumbs up. I am just starting on YouTube, and your help truly means a lot to me. And if you enjoyed this video, I am sure you're going to love this other one on the left side of the screen. What would really happen if you traveled at light speed? In this video, we explore how space and time warp as you approach light speed, and what you'd actually see on a journey across the stars. I talk about the mind-bending effects of relativistic travel, the energy required to reach near light speed, the cosmic speed limit that shapes our universe, and much more. See you there.